Okay, so I just wanted to give you guys a video that kind of shows again how to find each one of the details, like the holes, the asymptotes, and so on. And so remember, for vertical asymptotes, we're setting the denominator equal to 0. So I'm just going to put in here denom equal to 0. And even if it's something like x squared, we're still setting that equal to 0. So we're taking the x squared minus 8x plus 12 and factoring it. Right? And remember, factoring, we're just finding two numbers that multiply to 12, add to -8. If you need the X method to do that, that's fine, just on the side, right? Two numbers that multiply to 12, add to -8 would be -6 and -2. And so that's why I've factored the denominator as x minus 6, x minus 2. Right? I'll leave the numerator for now. And so we say, well, the denominator definitely can't be 6. Or I should say the x value can't be 6 and it can't be 2, because those are exactly the numbers that would turn the denominator equal to 0. All right, so if I were to set each one of these equal to 0, I would get 6 and I would get 2. And so generally we were saying, okay, so our vertical asymptotes are 6 and 2, but we have to consider the fact that one of those might be able to be eliminated. If I factor the numerator, which I'll put that in green, if I factor x squared minus 4, I can think of that as two numbers that multiply to -4, and there's nothing in the middle, so they would have to add to 0. All right, so that would be -2 and +2. So I can factor the numerator as x plus 2 and x minus 2. And the only reason we're doing that is to make our lives a little bit easier when we have to solve things, but also to say, well, is one of these vertical asymptotes actually a whole? And the only way we know it's a whole is if I'm able to cancel it out. And I am. There's a factor here of x minus 2 and x minus 2 on the denominator. I can cancel those out. So that means that x equals 2 is actually a whole. It's no longer a vertical asymptote. I was able to kind of eliminate that problem, cancel it out. So it actually shows me that 2 is a whole, not a vertical asymptote. So I'm going to take this one off. All right. 6 still stays there. 6 I couldn't cancel it out anyway. So it's still a vertical asymptote. It's still down there. I wasn't able to cancel it out. But because I could cancel out x minus 2, that answer of x equals 2 becomes a whole now. And then we can still say our domain is still going to be both of those numbers. We don't want x to equal 2, and we don't want x to equal 6, because again, if I look at my original problem, 6 and 2 were both the numbers that would turn that original problem, turn the denominators to 0. And then when we look at our asymptotes for horizontal, we say, what's happening here? What's our leading terms? So I'm going to erase this. Our leading term on the numerator is x squared. Our leading term on the denominator is x squared. So we say, let's compare those two. X squared over x squared technically would cancel out, and I would just be left with our coefficients. Because their coefficients are 1, we just say y equals 1. 1 over 1, which simplifies to 1. That means y cannot be 1. That's our little asymptote line. And then for intercepts, we're just saying, how can I make the other variable 0? How can I make y equal 0? So we can either set y equal to 0, or a quick way is, I have a fraction. The only way a fraction can equal 0 is if the numerator is 0. So I'm just going to let the numerator equal 0. That's kind of our quick way. Numerator is x squared minus 4. Set it equal to 0. I end up with x squared equaling 4. Oops, because I add 4 to both sides. And then when I square root, I actually end up with plus or minus 2. All right, so that means my intercepts are going to be at +2 and at -2. But then I have to consider the fact that, well, we already said x cannot be +2. So I don't want to write that as one of my asymptote lines. So actually the only good answer is x equals -2. It's like +2 is an extraneous solution because it's not even in my domain. And then lastly, y-intercept, usually the quick one to find, just because we're plugging in 0 wherever we see x. And there's a lot of x's in this problem, so I'm going to plug in, I'll say y equals 0 squared minus 4. And then on the denominator, 0 squared minus 8 times 0 plus 12. Oops, there we go. And then we just simplify. 0 squared minus